Again, just two more examples on these simultaneous equations where you've got a linear and a quadratic. Okay, so again here we've got one where we've been asked to find the intersection of a curve and a line. I mean, that's just a wordy way of saying solve these simultaneous equations because they need to be equal to each other. And again, what we want to do here is try and substitute in y from the linear into y in the quadratic. Okay, you don't really want to make x a subject here. If you make x a subject, you're going to get 10 minus y, and when you put it into the quadratic, you're going to have to square it by there and times it all by 6, and you're going to get something quite nasty looking in terms of y. Whereas if you're a bit more sensible, you can make y the subject of this. I mean, it's equally bad. It's just 10 minus x rather than 10 minus y. But when you substitute in now, that's going to go in the left-hand side on its own and nowhere else. Okay, so logically it does make more sense to make y the subject. So now if we come down from here, and I put 10 minus x on the left in place of y, okay, that's my substitution. And then I've got x squared minus 6x plus 14. This is now no different to what you were doing at GCSE anyway. So you need to get 0 on one side, easier to do that on the left. So I need to add an x, so that's going to get me minus 5x, and I need to take away 10, that's going to get me 4. Okay. Now it doesn't say work into two decimal places, which tells me that this one does factorise. Okay. You can use a quadratic formula if you want to, because you'll have a calculator for your exam, but this one does factorise x minus 1 and x minus 4, giving us then the integer solutions of x equals 1 and x equals 4, and you can get them, like I say, from the quadratic formula as well. We are though looking, like we did in the previous video, looking for the coordinates. So you will now also need a y part to go with each of those x parts, but we've got up here, we've got an equation for working out y. It says to do 10 take away x. So to work out y, I'm going to do 10 take away 1, which is 9. And then to work out this value of y, I'm going to do 10 take away 4, which is 6. And I've got my coordinates for where the curve and the line intersect twice, because the line crosses the curve twice if you plotted it out. And then the last one then, okay, looks a bit odd, this one. And that's because rather than having y equals, look, the y term is sort of embedded there with an x term. Makes it a little bit trickier to sub in, but not too bad. Again though, I don't really want to make x the subject, because if I do that I'm going to have to square it on that first term, and I'm going to have to put it in on that second term as well. It's going to go needlessly complicated. So let's make y the subject, because y only appears once in the quadratic. Now, we've got minus y here. The rules of changing a subject is you can't have minus y, so I'm going to have to bring that y to the right-hand side. So that's going to give me 10 plus y, but I want y to be on its own, so the 10 is going to have to go and be taken away. So x minus 10 equals y. So I've made y the subject there. All I've got to do now is rewrite my quadratic with x minus 10 in the place of y. So x squared plus x, this is where my substitution happens, x minus 10, and that all equals 168. What I need to do now is tidy that up into a quadratic that equals 0, and then I can start going about solving that. So we've got x squared, we've got another x squared from expanding there, we've got a minus 10x, and on the other side, the right hand side, we've got 168. To solve a quadratic, it needs to be equal to 0. So if I tidy this up a bit, I've got 2x squared minus 10x, and then I need to bring that 168 over to the other side. So minus 168 there, and that equals 0. Okay. Few options here. Easiest method, if you've got a calculator, use the quadratic formula to get your values of x. You could factorise it like it is there now, but you'd have to use the harder A, B, C longer factorising method. You could also divide it all through by 2, and it makes it a bit easier to factorise. Whichever method you choose to solve that, you should end up with x equals 12 and x equals minus 7 for your two values of x. We're not finding a coordinate this time, so that's actually finished. And that's how you solve simultaneous equations where one is linear and one is quadratic. You change the subject of the linear, you substitute it into the quadratic wherever that letter appears, and then set up a nice quadratic that you can solve either by factorising or by using the formula.